Hello, welcome to Chem Past Papers. In this video, I'm solving IGCSE Chemistry Paper 2, Variant 2, May-June 2023. I'll explain every correct answer, show you the traps, and give you exam tips to help you score higher. This is part 1 covering question 1 to 20. So let's begin. Question 1. 4 physical changes of ethanol are listed: condensation, evaporation, freezing, boiling. In which changes do the particles move further apart? So let's start with the first one, condensation. Changes from gas to liquid, so particles come closer. Evaporation changes from liquid to gas, so that means particles move apart. Particles come closer, not moving apart. And boiling, particles move apart. So the correct answer is option C, which is 2 and 4. Question 2. An atom of element X contains 5 protons, 6 neutrons, and 5 electrons. Which statement about element X are correct? Now we evaluate the statement. First one, X has an atomic number of 6. Atomic number is equal to number of protons. So number of proton here is 5. So this is out. Not correct. Number 2, X has a nuclear number of 11. Nuclear number is equal to proton plus neutrons. So proton 5 plus neutron 6 equals to 11. That's correct. X is in group 2 of the periodic table. That's wrong. X is having 5 electrons. So our group is equal to the number of electrons in the outer shell. And the electronic configuration is 2, 3, making it 5. So X is group 3, not group 2. So this out. And lastly, X is in the second period of the periodic table. The number of shells equal to number of periods. So if we count the shell here, we have only 1 and 2. So it's in period 2. So that's correct. So our answer is option D, which is 2 and 4. Common mistake: confusing atomic number and mass number. So tips to remember: atomic number is equal to number of protons. Mass or nuclear number is equal to protons plus neutrons. Question 3. Ammonia is a covalent molecule. Which diagram shows the outer shell electron arrangement in a molecule of ammonia? This question is about dot and cross diagram of ammonia. Ammonia is NH3, so that means you have your ammonia as a central atom surrounded by 3 hydrogen. Now, so the correct diagram must have or must show 3 shared pair of electrons, because ammonia is number 7, so the electronic configuration is 2, 5. That means it needs 0 electron to complete the shell. So if you look at all the options showing us that ammonia is sharing 3 electrons, so that cannot help us. Then next, ammonia must have lone pair of electrons. So ammonia is sharing 3 electrons, so 2 will remain. So those 2 must be on the shell. So if you can see A, it's not there, and then B is not there. So A and B is out. We haven't C. And then lastly, all the atoms must have a stable electronic configuration after the bonding. So let's check for C. Nitrogen 1, 2, 3, 4, 5, 6, 7, 8 complete. Hydrogen 2, hydrogen 2, hydrogen 2 is complete. So that means our answer is option C. Why is D not the correct answer? D is not the correct answer because even though the nitrogen has a complete shell, the hydrogen do not have complete shell. They are supposed to have 2 electrons only, because remember the first shell can take the maximum of 2 electrons only. But here, the hydrogen is having 1, 2, 3, 3 each, which is wrong. That is why D is not the answer. So C is our correct answer. Common mistake: student forgetting the lone pair of electron. So please don't forget the lone pair of electron. Like we said, the electronic configuration is 2, 5. It's sharing only 3. 2 will remain. I'm not throwing away that 2. We are writing it on the shell, making our nitrogen to be complete. So question 4. Which structure does silicon 4 oxide most closely resemble? The question asks about the structure of silicon 4 oxide. Now, silicon 4 oxide is a giant covalent structure. Diamond also is a giant covalent structure. So, and silicon 4 oxide looks like diamond, not graphite. So our answer is B. Why are others wrong? Carbon dioxide is simple molecule, so it's wrong. Graphite is in layers, so it is wrong. Sodium chloride is a ionic lattice. So B is our answer. Question 5. Substance P conduct electricity when solid. Which particles move in solid P so that it can conduct electricity? We have anions, cations, electrons. Now substance P conduct electricity when solid. So take note of this statement: when solid, very important. That means that it must be a metal. Now in metals, electricity is conducted by free electrons. So the answer should be electrons only, which is option D. Question 6. Which equation represents a chemical change? Now let's look at them. A chemical change, new substance is formed. So A is not a chemical change because it's just changing from solid to liquid, change of state. So it's not correct. Then B, new substance is formed, aqueous, and then we have this. B is correct. And why is C not correct? C is dissolving. So still potassium chloride, no new substance, just dissolve in water. Then D is not correct because just ions, they are just ions staying in a solution. There's no reaction. So option B is the correct answer. So common mistakes, students think dissolving is a chemical change. No, dissolving is not a chemical change. So if a new substance is formed, it is a chemical change. If there's no new substance formed, then it's a physical change. So option B is the correct answer. Question 7. Which sample contains the largest number of molecules? Now, the number of molecules depends on the number of moles. And remember that our formula, number of moles is equals to mass over molar mass. So let's get the molar mass of compounds we have here. So for methane, we 12, that's the atomic mass of carbon, plus 1 multiplied by 4, that's 12 plus 4, which is 16 gram per mole. Then oxygen, the atomic mass of oxygen is also 16. So 16 multiplied by 2 is 32 gram per mole. Then for phosphorus, the atomic mass of phosphorus is 31. Please don't forget to always use your periodic table. The number down here is the atomic mass. Check our relative atomic mass of phosphorus is 31. So we have 4 of it here. So 31 multiplied by 4 is going to give us 124 gram per mole. Option D is already out because it is volume, not mass. That means the answer is between A, B, and C. So the number of moles of methane will be mass over molar mass 16 over 16, which is 1. For oxygen, will be 16 divided by 32, which is 0.5. Then for phosphorus, will be 16 divided by 124, 0.13. So remember we said the number of molecules depends on the number of moles. So that means the one with the largest number of molecules will be the one with the largest number of moles. So here, methane has the largest number of moles, which is 1. So our answer is A. Common mistake, students confuse mass with number of particles. Please, they are not the same. More moles will be equals to more particles. So the more the number of moles, the more the particles. Question 8. The concentration of a sample of dilute aqueous sodium hydroxide is found by titration. The apparatus used is shown. Which information is needed to calculate the concentration of dilute aqueous sodium hydroxide in mole per DMQ? Now, this question asks about information that is needed to calculate the concentration of sodium hydroxide from titration. To calculate concentration, you will need concentration of acid. So here, option C is already out because we don't have concentration of acid. We need volume of acid used. Volume of acid used. So D rather is out. Then we need volume of alkali used. Our alkali is sodium hydroxide. A and B, volume of sodium hydroxide used is stated there. So we go to the last column. We don't need molar mass to calculate concentration. So that means the correct answer is B, because it's the one that stated that we don't need molar mass. Common mistake, students think molar mass is always needed. It is not. So titration formula uses volume. Number of moles is equal to concentration times volume. So we don't need molar mass in that calculation. Question 9. In experiment 1, aqueous copper 2 sulfate is electrolyzed using graphite electrode. In experiment 2, aqueous copper 2 sulfate is electrolyzed using copper electrode. Which statement identifies a half equation for a reaction of one of the electrodes? So let's look at them one after the other. Now, this question compares electrolysis using graphite electrode and copper electrode. With graphite electrode, which is inert, at the anode, hydroxide ions are discharged because it is aqueous. So hydroxide ion will be discharged. That means our half equation is going to be this or this. So our answer is between A and D. B and C are already out because the equation here is wrong. Then let's check why B and C are wrong. B, hydrogen forms only if hydrogen ions are present. Now for C, that equation is for a cathode, not an anode. And then for D, oxygen is produced at the anode, not at the cathode. Look at it here. So it is at the cathode. So the oxygen is produced at the anode, not at the cathode. So C is wrong. So therefore, our answer is A. In experiment 1, the half equation for anode reaction is this. So because it is aqueous, that means hydroxide ions are discharged, and this is the correct half equation. Exam tips: always remember graphite electrodes are inert, while copper electrodes are reactive. Question 10. Which substance is not produced during the electrolysis of concentrated aqueous sodium chloride? Take note of what they are telling you about the electrolyte. Is a concentrated aqueous. In aqueous electrolysis, at the cathode, hydrogen will be produced because sodium is more reactive than hydrogen. And then at the anode, chlorine will be produced because chlorine is a halogen. In solution, sodium hydroxide will be formed. But sodium metal is not produced in water because sodium is too reactive. So that means that from our options, the substance that is not produced during the electrolysis would be sodium. Sodium is more reactive than hydrogen. So hydrogen is going to be produced instead of sodium. Sodium can only be produced if it is molten sodium hydroxide. Common mistake. Students think sodium forms because it is sodium chloride. It does not. In aqueous electrolysis, always remember hydrogen forms instead of reactive metals. Unless a situation where you have less reactive metals like copper, but for reactive metals, hydrogen forms instead of reactive metals. Question 11. Methane bonds in excess oxygen. The equation of the reaction is this. Bond energies are shown. These are the bond energy. So which is the energy change for the reaction? How to solve this? Energy change is equal to energy of bonds broken minus energy of bonds formed. So bonds broken are the reactant. So let's look at it. We have methane, which is, remember, whenever you are solving energy change, you need to write your equation in their displayed formula. If it is not written like that, for example, in this case, it's not written in display, so we have to write it here so that we can know the bond, then we can assign the correct bond energy. Now for this reactant, we have carbon to hydrogen bond, one, then we have 2, 3, 4. So we have 4 carbon to hydrogen bond. So it's going to be 4 multiplied by 410. Plus we have oxygen and oxygen double bond, which is 496 for 2 of them. So it'll be 2 multiplied by 496. Now if we look at our option, we have already eliminated B and D. So let's go to the product. We have carbon dioxide and water. So the same thing we are going to do. You write their display formula. So this is for carbon dioxide, and then water. This is for water. So we insert their bond energy. We have 1 carbon double bond to oxygen, another carbon to double bond to oxygen. So we have 2 of it. It's going to be 2 multiplied by 805. Then we have here oxygen, hydrogen 1, oxygen, hydrogen 2. So that means you have 2 of this, which is 2 multiplied by 460. But then we have this 2, which is multiply everything. So we'll put that in bracket. So this is our reactant as energy of bond broken, and this is our product energy of bond formed. So let's look at our option, which one aligns to what we have written here. So obviously to be A. So A is correct answer. Exam tip. Always remember energy change is equal to bond broken minus bond formed. Don't reverse it. It's bond broken minus bond formed. Reactant minus product. Question 12. Which change increases the rate of reaction by decreasing the activation energy? So we have option addition of catalyst, which is correct answer. So why is addition of catalyst correct answer? Only catalyst lowers activation energy. All these ones that you mentioned decrease the size of solid reactant, increase the concentration, increase the temperature. All these ones, what they do is that there will be more collision, more energetic collision, but they do not lower activation energy. So answer is A, which is addition of catalyst. Common mistake. Students think temperature lowers activation energy. It does not. Okay. If the question says activation energy, just think of catalyst. Amongst the factors affecting rate of reaction, only catalyst reduces or decreases the activation energy. Question 13. In the contact process, sulfur dioxide is reacted with oxygen to form sulfur trioxide. Which conditions are used in this reaction? Now, this is about contact process. Sulfur dioxide reacts with oxygen to form sulfur trioxide under the following condition. Temperature is 450 degrees Celsius, So our answer is between C and D. A and B is out. Then pressure is 200 kPa. You have to be careful here. Check the unit of the pressure. It's in kPa. So we are looking at 200 kPa. So option D is out. That means our answer is C. Our catalyst, of course, is vanadium 5 oxide. Common mistake: students sometimes confuse contact process with Haber process. So please take note of the conditions for contact process and the conditions for Haber process. They are different. Question 14. Which reaction is reversible? Now, look at them. Option D is our correct answer. White anhydrous copper 2 sulfate turning blue when water is added. Now, it can be reversed by heating. So the reaction is reversible. Why are others wrong? A, an iron nail rusting when left in moist air. It is irreversible. Limestone reacting with an acid to form carbon dioxide gas is irreversible. And also, of course, burning of magnesium is also irreversible. So option D is our answer. So please remember, reversible reaction usually involves hydration and dehydration or equilibrium. Whenever you hear hydration, dehydration, and hydros, that's reversible reaction. Or you see the equilibrium arrow, tap equilibrium completely. Question 15. The equation for the reaction of sulfur dioxide with acidified potassium dichromate 6 is shown. What is oxidized and what is the oxidizing agent? So oxidation is gain of oxygen or loss of electron. Then reduction is loss of oxygen or gain of electron. Remember your oil rig. Oxidation is loss of electron, reduction is gain of electron. So let's look at this option that we have. We have A, sulfur dioxide changes to this. So there's increase in number of oxygen, so that's oxidation. So that means sulfur dioxide is oxidized. So our answer is between option A and B. C and D are out. Then oxidizing agent. So let's look at our chromium for the A option. This is chromium. Look at the charge from negative to positive. So it is reduced. That is, chromium is reduced. And if chromium is reduced, it is the oxidizing agent. The substance that is reduced is the oxidizing agent, and the substance that is oxidized is the reducing agent. So since chromium is reduced, it is the oxidizing agent. So our answer therefore is A. Common mistake: students confuse oxidizing agent with oxidized substance. Please, it's not. So oxidize means to lose electrons or gain oxygen, just like I said, while oxidizing agent is the substance that is reduced. The one that is reduced is the oxidizing agent. Please take note of that. Next question, question 16. What is the definition of a strong acid? Let's look at option A proton acceptor that is completely dissociated in aqueous solution. So it is wrong because it's base that are proton acceptors, not acid. Then option B, a proton acceptor that is wrong also. Anything acceptor is wrong. Proton donor, okay, that means between C and D. So let's look at C, a proton donor that is completely dissociated in aqueous solution. That's correct. And let's look at why D is not is correct option. A proton donor that is partially dissociated. So that is wrong. Why is it wrong? The reason why D is wrong is because strong acid completely dissociate in aqueous solution, while weak acid partially dissociate in aqueous solution. Next question, question 17. Which statement about amphoteric oxide is correct? Now, we have to define our amphoteric oxide. So the amphoteric oxide are substances that can behave as both acid and base. So amphoteric oxide react with both acid and base. So common examples are aluminum oxide and zinc oxide. So from our option given to us, A, look at it, it says that they are made by combining acid oxide with basic oxide. That is wrong. B, they react with water to give a solution of pH 7. That is wrong. Option C, they react with both acid and base. That's correct. Option D, they do not react. That's wrong. So our answer is C. Question 18. Copper 2 carbonate is formed when aqueous sodium carbonate is added to aqueous copper 2 nitrate. The ionic equation for the reaction is this. How is pure copper 2 carbonate obtained from the reaction mixture? We have option available. So copper 2 carbonate is a precipitate. Look at it. How do we know? look at it, is solid. Aqueous and aqueous will give us solid. Remember precipitation reaction, we're talking about two soluble solids. Remember precipitation reaction, we're talking about two soluble salts to give us an insoluble salt. So if you look at this reaction, aqueous, that means it is soluble to give us solid, which is insoluble. So we are looking at preparation of salt by precipitation. And in preparation of salt by precipitation, what we do is that we filter to collect the solid, and then we wash to remove impurities, and then we dry to remove water. So the correct sequence should be filter, wash, and dry, which is option D. Common mistake: students use crystallization step for precipitate. No. In preparation of salt by precipitation, there is no crystallization. So if a solid is formed immediately, then you think of precipitation, and the method should be filter, wash, dry. Please don't forget, if a solid is formed immediately like this, but if it is a solution that is formed, then you think of other method of preparing salt. Question 19. Q and R are elements in the same period of the periodic table. Q has 7 electrons in its outer shell. R has 2 electrons in its outer shell. Which statement about Q and R is correct? So let's take them one after the other. Option A, Q is a metal and R is a non-metal, which is wrong. 7 outer electrons means non-metal for Q, so Q is not a metal. Then B, Q and R have the same number of electron shell. Same period will be equal to same number of electron shell. So from our option given to us, option B, Q and R have different number of electron shell. It's also wrong because same period will be equal to same number of shells. So if you look at it from our statement here, we are told that Q and R are the same period. So they are supposed to have the same number of shells. So B is out. Then C, R is found to the right of Q in the periodic table. It is also wrong. R is to the left, not right, because R is a metal, Q is a non-metal. So R is to the left, not to the right. Then option D is our correct answer, because across a period, proton number increases from left to right, metallic character decreases, number of shells stay the same. So if you look at this, perfectly fit D, the proton number of R is less than the proton number of Q. And this is because R comes first in the periodic table before Q. So it's having less number of protons. Question 20. Lead 2 sulfate is an insoluble salt. Which reaction produces a mixture from which lead 2 sulfate is obtained by filtration? Now from the first sentence, you already know that this is preparation of salt by precipitation method. Okay, so to form an insoluble salt by precipitation, there are two things that you need. There are two soluble solutions. So the 2 nitrate is soluble, sulfuric acid is soluble. So we are looking at, so let's look at the options to see which one is correct. A, adding the 2 carbonate to dilute sulfuric acid, that is acid-base reaction, not precipitation, so it is wrong. Adding solid the 2 hydroxide to dilute sulfuric acid, also the same thing, it is wrong. Option C, adding metallic lead to dilute sulfuric acid. Now that is metal plus acid, which will give us gas, not a hydrogen gas, not a precipitate. Then lastly, D, adding aqueous lead 2 nitrate to dilute sulfuric acid is our correct answer. Why is it so? Lead 2 nitrate is soluble, sulfuric acid is soluble. So they will form lead 2 sulfate, which is insoluble and can be filtered. Please remember this, precipitation reaction is soluble salt plus soluble salt to give us insoluble salt. That will be the end of part 1. We continue in part 2. Don't forget to like, share, and subscribe.